Hello students, welcome back to the next module of the chapter Oscillation. In the last module we have defined linear SHM and we also saw the mathematical expression for force acting on a particle performing linear SHM. In this module we are going to derive a mathematical expression for the differential equation of linear SHM. So let's start with the differential equation of linear SHM. To begin with, as we already know from the definition of restoring force, F is given by the formula. Yes, F is equal to minus kx. What is k here? So k is force constant and x is the displacement of the particle from the mean position. Now in physics, force can also be given by Newton's second law of motion and the formula is force is equal to mass into acceleration. In symbolic form, I can write now F is equal to ma. Say, let it be equation number 2. So we have got two equations, both representing force. Let's move ahead. Now, acceleration in second formula is given by the basic definition, rate of change of velocity. In mathematical form, it is dv by dt. So let us write a as dv by dt. Also, velocity is given by the definition rate of change of displacement, that is dx by dt. So let's write the formula, v is equal to dx by dt. Now let us substitute the value of v in the formula of a, and therefore acceleration now can be written as a is equal to d by dt of dx by dt, where I have substituted now the value of v as dx by dt. And finally acceleration can be written in mathematics as a is equal to d square x by dt square. So we can write acceleration as second order differentiation of displacement with respect to time. Now let us substitute the value of a in the equation number 2. So the formula of force now can be written as, so F is equal to, which was earlier mass into acceleration ma, will now become m into the value of a as d square x upon dt square. Say it is equation number 3. Now let us substitute this new value of force, that is equation 3, in equation 1. But what was equation 1? Equation 1 is F is equal to minus kx. So let us substitute 3 in equation 1. So now your equation 1 becomes m d square x by dt square is equal to minus kx. Dividing both the sides by m we get, so LHS we get rid of m and LHS becomes d square x by dt square and RHS becomes minus of k by m into x. Taking RHS on LHS, it becomes negative sign becomes positive, and therefore I can write d square x by dt square plus k by m into x is equal to 0. Students, this is one of the form of differential equation of a particle performing linear SHM. Now k is constant, m is constant, so k by m on the whole is constant. Let us substitute k by m by another constant omega square, and hence equation 4 becomes d square x by dt square plus, yes, instead of k by m we'll write omega square, and plus omega square x is equal to 0, where omega is constant called as angular velocity. Why angular velocity? We will see in forthcoming modules. So right now equation 4 and equation 5 are two different forms of the differential equations of linear SHM. Now note, k is a positive constant, m mass is always positive, therefore k by m on the whole is always a positive quantity. Since k by m is positive and k by m is omega square, therefore omega square is also positive. Now if omega square is positive, that means omega can be either positive or negative. So students, in this module we have derived a very important derivation, differential equation of linear SHM. That's all in this module, students. See you in the next module.